Dear students, in this part video, I would like to explain or we are going to discuss about question and answers explanation for Grand Test 1. Okay. So the first one in our physics syllabus is match the following. So under the match the following, they are given to virtual image formed by a convex lens, and second one is virtual image formed by a concave lens. So for these two, which is the suitable options among the in the types other side. So the first one is what is that they are asking that virtual images formed by a convex lens. Generally, in a convex lens, we know very clearly a virtual image is formed when an object is placed between optic center and focus, or focus and optic center. Just I will draw a diagram for understanding of you once again. So it is a convex lens, that is we know that it is a principal axis. So for this one, it is the optic center. We have considered that it is the focus. When the object is placed between the optic center and focus, this arrow mark AB is represent the position of the object. Now from this object we consider two rays. One ray parallel to the principal axis. After that, it must be passing through the focus in other side. That is, we know that. And second one, we consider passing through the optic center. So without any deviation, it will be moved like this one. So this. But when the object is placed between the optic center and focus on one side of the convex lens, after the refraction, the first refracted ray and the second refracted ray never meet. But where the image will be formed means the first refracted ray produced to backward, second one produced to backward, both are meet in the same side of object at one point, that is A dash, B dash. This is the virtual image, because of we know that after the reflection or refraction, the rays are either really meet at a point, real image will be formed, or appears to meet at other point, virtual image is formed. Now here in this diagram, we are observing that after the refraction by the convex lens, the rays are not meet, but they appears to meet at one point. So this is the image will be formed. So that's why it is which type of image? Magnified image. So virtual, erect and magnified image is formed in the same side of the object. That is the first thing is there. And in the second one is virtual image formed by concave lens. And we know very clearly, so concave lens always forms the virtual images only wherever the position of the object. And we know very clearly, when the object is placed at infinity distance, the image will be formed at the focus. It is highly diminished and virtual. But except the infinite distance, beyond the center of curvature to up to the optic center, at any position, the image will be formed between the optic center and focus. It is virtual, erect and diminished image. So that's why the second one is diminished image. So next, we come to the third one. What is the direction of magnetic field lines of a ball magnet? So we know that So this is the diagram represented that one. So NS is a bar magnet. When we can take the magnetic compass and place it either at the north or south side, and we are observing that in the magnetic compass the north pole always moves towards south is there. So that's why means directly I said that. So the magnetic field lines are outside of a bar magnet always move from north to south, but inside the bar magnet the lines will be moved from south to north. So that's why, but you can write the which answer means simply north to south in outside, that is the answer. Next, fourth one, we are observing that in which situation the incident ray does not deviate from its path. In that one. So they are given two situations. First situation, ray is passing along the principal axis, and second one, ray is passing through the optic center. So we know very clearly. So if it is the ray means convex lens, I can say that it is the optic center, it is the principal axis, this one. If incident ray is passing along the principal axis, we know that. So at the first refraction we draw a tangential line. So it is appears to what is that one? The incident ray appears to normal for the refracting surface. That's why when the incident ray is fall normally on reflecting or on refracting surface without any deviation, it will be moving along this. This is the refracted ray. So that's why if the incident ray passing through along the principal axis, it is not deviated. That is so. First one is correct, and second one, what is that one? If the ray is passing through the optic center, if this is the incident ray passing through the optic center, at that time also the ray is not deviated. But we know very clearly the ray is deviated slightly, that is the lateral displacement. But the lateral displacement produced by the lenses when passing through the optic center is very, very less. Due to that one, we are not considered that. That's why when the ray is passing through the principal axis and as well as optic center, it is not deviated. That's why both two statements are correct, means both P and Q. Next one, write the formula to find the focal length of a lens when object distance u and image distance v. Means so they given object distance and image distance to us. Then which formula we are used to find the focal length? Means we know directly is there 1 upon f is equals to 1 upon v minus 1 upon u. Here f is represented the focal length, u is the image distance, and u is the object distance. U and v values are substituted in this one by using the rules for sign conversion. While substituting, then you find the focal length is there. Next one, question number 8. What is the minimum focal length of eye lens of a healthy person? So this one we know. In the human and colorful world chapter, we are clearly discussing that. So when a person can able to see the distant object, our eye with help of the ciliary muscles it will be extended, means increase the focal length. So that's why, so when we can able to see the far objects, the focal length of our eye lenses are 2.5 centimeter, it is the maximum. But when you are able to see the nearby objects or at least distant vision, so then automatically our eye lenses with help of the ciliary muscles will be contracted. So then at that time decrease the focal length and increase the converging power. So the focal length, the minimum focal length of our eye lenses is 2.27. It is when we able to see the nearby object, and the maximum is 2.5 centimeter when we are able to see the far objects. At that time our eye will be without any strain, but here strain is there. focal length is less, converging power is more. Okay, focal length is more, converging power is less because of P is equals to 1 by f in meters. That is, we know that. So these two are the reciprocal. If f is less, P is more. If f is more, P is less. That is one is there. So our answer is 2.27 centimeters. Next one is there. Okay, among the following, which will be have the highest specific heat is there? So water, seawater, ice, and iron. Okay. Now their values in the CGS unit, we know that calorie per gram into Kelvin is there. So water specific heat is 1 and seawater is 0.93, ice is 0.50 and iron is 0.11. So that's why which has the highest specific heat, obviously water. Next one, in section 2, question number 13. Convert 283 Kelvin into degree Celsius. So that's why 13th one we are observing that 283 Kelvin is equals to dash degree Celsius. That is the meaning of that. Okay, we know the formula. C is equals to K minus 273. C is the Celsius scale, K is the Kelvin scale, and 273 is the value. But already you know that how we can do. So in the place of K, we substitute which one? 283. C equals to 283 minus 273. Then what is that value? 10 degree Celsius. So that's why 283 Kelvin is equals to how many degrees Celsius? 10 degree Celsius. This is the one is there. Next, 15th one. Draw the magnetic field lines of a bar magnet. So this is a bar magnet. Every bar magnet has two poles, north pole and south pole. Now we can take a magnetic compass. It is placed at the corner of the north pole of a bar magnet after it is placing on a white chart of the drawing board. Now, so we put the dotted lines with help of the magnetic compass by changing its position. So the graph is just like this one is there. So the magnetic field lines are from this one. We are understanding that they started from north and ends at the south in outside of a bar magnet. That is the meaning of that. So this is one is there. Next one, question number 17. Why does presbyopia find in aged people? So that's why generally we know that three type of eye defects are there. That means generally occurs in the human eye regularly: myopia, hypermetropia, and presbyopia. Remaining other one is there astigmatism, blindness, color blindness. That is the another one is there. But among myopia means we know that a person can able to see nearby object but not the far object. Hypermetropia means a person can able to see the far objects clearly but not the nearby objects. But presbyopia means a person cannot able to see nearby object as well as a far object. Means at a time means a person cannot able to see the near object and far objects. That defect is called presbyopia. So while in the aged people the presbyopia is occurs means generally the presbyopia is coming along with the aging of the person. But why means when the age is gradually increases, so our eye muscles is nothing but ciliary muscles will be losses the power of accommodation. Power of accommodation means you know that Okay, so when you can see the for objects automatically increase the focal length of the eye, and when we can see the nearby object, so decrease the focal length. This is called as the power of accommodation. So when in case of along with aging, our ciliary muscles or our eye lenses are gradually losses the power of accommodation. Due to that one, we are unable to see nearby objects and as well as far objects clearly. That is the main reason for the which one presbyopia is there. Next one, 19th one, we are observing that what differences do you notice in figure 1 and figure 2 with respect to the refracted rays. So based on the refracted rays, we are observing that what type of difference we are observing from the A diagram and the B diagram. Here the diagram A, we are observing that ray means the light ray travels from rarer medium to denser medium, but in the B diagram light ray travels from denser medium to rarer medium. So we know that when light ray is travels from one medium to another medium, it will be slightly deviate from its path, that is called refraction. The main reason for the refraction is change the speed of light. So now here, that is according to the wave theory concept I explained clearly, so while teaching in the physical classes. Now here we are. In this one, when the light ray travels from rarer medium to denser medium, the light ray appears here bend towards the normal. So in this one, means when light ray travel from rarer to denser medium, three situations will be happen. We know that light ray deviate from this path and moves towards the normal. Second one, angle I is always greater than the angle R, or angle R is less than the angle I. That is the second one. And third one, speed of the light will be decreases. Next, in the second case, in the denser medium, when the light travel from denser medium to rarer medium, the refracted ray move away from the normal. Here move towards the normal, here move away from the normal. In this case, angle I less than the angle R, or angle R less than the angle I, means just opposite to the A. And third one, speed of the light is increases. That is one. So what type of differences are we are observing from these two diagrams? Means simply from the diagram A, we are observing that the ray bends towards the normal. In the diagram B, the ray move away from the normal. The two differences we are noticed easily. And the second one, here angle I greater than angle R, here angle I less than angle R. Third one, speed of the light is decreases, speed of the light is increases. These three differences majorly we are observing from these two diagrams. Next, in section 3, question number 22. A boy who is suffering from eye defect has been given a prescription as -2D. Based on this information, answer the following. So two questions were given that in the 22nd is the first one is identify the eye defect he was suffering, that is the first one, and second one is write the nature and focal length of the lens, that is the second one is there. So first one is a person means when a person is consult the doctor in the prescription he advises use the -2D lens according to the question. That's why based on that statement you can answer these two following. First one, the person suffered with which type of eye defect, means simply we know that myopia. Why means I explain. Second one is write the nature and focal length of the lenses. So what is the nature and focal length means so nature means the person unable to see the far objects clearly. And what is the focal length means? F is equals to 100 by P. That is, we know that. Okay. So that is equals to 100 by minus 2. That is equals to minus 50 centimeter. This is the focal length. And what type of nature of the lenses we are using, that means, so to correct this one we are using the biconcave lens. So we are observing that actually we know the formula clearly is that F is equals to minus D. This is the formula of focal length of a myopia. So means convex lens focal length is always positive, concave lens focal length is always negative. That is, we know very clearly is there. Okay, so that's why already in the statement minus 2D is there. So if focal length is negative, power is also negative. If focal length is positive, power is also positive. Okay, so now let me come to this one. So a person minus 2D means immediately it is represented the myopia. Plus is there means symbol, it is the hypermetropia. So what is the nature and focal length of the lens means? The focal length of the lens is 100 by P, that is the formula. Means you know that P equals 100 by F, then F equals to 100 by P. That is equals to 100 by, what is the power P? Minus 2D. D is the units of the power, that is diopter. So 100 by minus 2, that is minus 50 centimeter. So like this one is there. So which type of lenses we are using to correct the myopia means biconcave lens are using that. So 23rd one is, what is electric current? Right, it's SI units or units. Electric current, we know the formula, I is equals to Q by T. I is the current, Q is the charge, T is the time. So current we can define in the two ways. The rate of flow of electrons in a conductor is called electric current, or the charge flowing through a conductor in a unit time is called current. So that is one is there. What are the units of electric current in both SI and CGS? In SI system, I is, what is that one? Ampere. Okay. So the SI unit of current is ampere. That is, we can write it is coulomb per second is there. So 1 ampere is equals to coulomb per second. And CGS units is, what is that one means? So biot. It is the name of the sign. So Maxwell per second is there. So these are the SI and the CGS unit of electric current. Next, 26th one we are observing that this is the diagram they are given in our question paper. Now let me finish this diagram and find the nature of the image is there. So for this one we redraw the diagram. You are observing that this type of way they are given means it is must be belonging to convex lens but not a concave lens, because in a concave lens object and image means S1 and S2 are both are in the same side above the principal axis only, but in case of convex lens only, so except the object is between focus and optic center, remaining cases object is above the principal axis, image is below the principal axis. That's why here which lenses they are using according to this one. So you must be use the convex lens is there. This is the symbol of convex lens. We know that very clearly. this symbol is represented the convex lens, and this symbol represents the concave lens. That is one is there. Here which lens according to the diagram? Convex. This is the optic center O, where I can set that simply. Okay. Or otherwise we draw the diagram like this. So here it is the S1 is there. Focus F2 to F2. So this is the diagram. It is the S1. It is the S2. So like this one. Okay. So what is the nature of the image means here? We can say if the object is placed between 2F2 and F2 means center of curvature and principal focus. So the image will be formed beyond the center of curvature or 2F1 is there. It is real, inverted and magnified image will be formed by this one. This is the nature of the image. Next 27th one is the magnetic flux and magnetic flux density. What is the magnetic flux means? The number of magnetic field lines passing through the cross-sectional area. So the number of magnetic field lines, okay, passing through the cross-sectional area is called magnetic flux. Magnetic flux density D is equals to pi upon A is there. Is nothing but the magnetic flux per unit area is called flux density. We know that what is the SI unit of this one? Weber. And what is the SI unit of this one means? Okay, Weber means simply Weber per meter square is there. So the number of magnetic field lines passing through the cross-sectional area is called magnetic flux. The magnetic flux per unit area is called flux density. Its SI unit is Weber, its SI unit is Weber per meter square. Its CGS unit is Maxwell, its CGS unit is Gas. That is we know very clearly is there. So now we are going to discuss the section number 4. Next in section number 4 means essay questions or long answer questions. Question number 29. Write the differences between convex lens and concave lens. We know very clearly what are the differences between convex and concave lenses. A lens here we are observing that a lens which is thicker at middle, thinner at the edges, convex lens. A lens which is thinner at middle and thicker at edges is called concave lens. Convex lens acts as a converging lens. It acts as a diverging lens. Its focal length is positive, its focal length is negative. It will be forms real and virtual image. It will be forms always virtual image only. The image formed by convex lens is may be either diminished or same size or magnified image, but the image formed by this one is always diminished image only is there. Convex lenses are widely used in various sources like to correct the hypermetropia in cinema projector in means glass slide projectors, and so this type of one is there, means burning glasses, number of other reading lenses like this one. Concave lens are used in so Galileo telescope. Next celestial means simply Galileo telescope. Next one to correct the myopia. So in these cases the concave lens are used is there. So a lens which is thicker at middle, thinner at edge. A lens which is thicker, thinner at middle, thicker at the edges is there. So it is the converging lens, diverging lens. Focal length is positive, focal length is negative. It will be forms real, virtual. It forms only virtual. Image formed by this one is either diminished or same size or magnified. It is always diminished is there. So it is widely used in the various sources like in the cinema projectors, glass sliders. Next one reading lenses, burning glasses like and this one is a Galileo telescope, and to correct the myopia, it is a hypermetropia is there. Next another one is also given, means during the writing the examination we can write either this one or this one. What is this? Heat, temperature, specific heat capacity and absolute temperature are Kelvin 0, means we can define this for one. What is the heat? We know that heat is a form of energy. It is always transferred from a body at higher temperature to a body at lower temperature. That is one. Heat is a form of energy. It is always transmitted from higher temperature to lower temperature of a body. What is the temperature? The degree of hotness or coldness of an object is called temperature. In this one, heat is also. Heat is a form of energy. It tells the information about the degree of hotness or coldness of an object. It is the degree, that is one different is there. Specific heat capacity is there. The amount of heat energy required to rise the temperature of 1 gram or a unit mass of a substance a unit mass of a substance through 1 degree Celsius or 1 Kelvin, that is called specific heat capacity. The amount of heat energy required to rise the temperature of 1 gram or 1 kilogram mass of a substance through 1 degree Celsius or 1 Kelvin, that is this one is there. Absolute temperature or Kelvin 0. So the temperature at which the movement of molecules cease to 0, that is absolute temperature. A temperature at which the movement of molecules in a system is ceases to 0, that is absolute temperature or Kelvin 0 or 0 Kelvin. Its value is 0 K, that is equals to minus 273.15 degrees Celsius, that is equals to minus 459.67 degree Fahrenheit. This one is there. Next one, question number 31. Under this A. So, prove how the resistance of a conductor depends on the length of a conductor. That one is there. Question number 31. How to prove resistance depends on the length of a conductor. First of all, we can construct one electrical circuit. a battery, plug key, ammeter, a resistor, means conductor. P and Q is the gap, like this one. So first of all, what we can do means, for proving the what is the relation between resistance and length of a conductor in this one. First of all, we can take a copper material or copper conductor of different in length and the same in area of cross section is nothing but, okay, so copper wire means 1 meter length of the copper wire having 1 millimeter square unit area. Next, in the second case, copper wire 2 meters length of copper wire having the 1 millimeter square unit area. In third, 3 meters length of the copper wire having 1 millimeter square unit area. So means what is the meaning? So the nature of the material means copper, copper, copper only, but length is 1 meter, 2 meter, 3 meter, but area of the cross section is constant. Means in this one we are observing that which is the constant here. Nature means nature of the material is constant, area is constant, but not which one, length, because of we prove between the R and L relation is there. First of all, we can take a copper wire of different in length like 1 meter, 2 meter, 3 meter, but having the same area of the cross section. Now, first of all, 1 meter length of the copper wire is introduced between the P and the Q gap in the circuit is there. So that is one R in the place of R, means in the R is represented that one. Now, so in the battery, okay, we keep the constant potential difference, means we are using the variable battery, okay, 12 volts battery. In the 12 volts battery, we have the, okay, adjustment capacity is there 3, 6, 5, 4 like that one. So now in the battery, for understanding of you, so we can keep which one 6 volt constant, but while writing the, okay, answer during the examination, don't have this. These values are just for your understanding only, this concept in this. So in the battery we can keep the 6 volts potential difference constant, means in the battery the knob we put exactly at the 6 volts. Okay, until entire the complete of this experiment we don't change the potential difference of the battery, okay, on the two ends of the conductor. That is one 6 volt, 6 volt, 6 volt means when you can take 1 meter, 2 meter, 3 meter, whatever the length of the conductor, so potential difference is constant. That is the meaning of that. First, 1 meter length of the copper wire introduced between the P and the Q in the circuit, and key is closed. When the key is closed in the circuit, okay, potential difference is created and current will be flow. How much current is flowing through this circuit? We can observe with the help of the, okay, micro or milliammeter is there. For example, just, okay, in for understanding of you, so 1 meter length of the wire introduced between the P and the Q, how much current will be flowing? Just your understanding, 4 milliampere is there. 4 milliampere current is there. Now after that one, remove the, okay, 1 meter length of the wire and introduce the 2 meters wire in the P and the Q, and observing the ammeter reading. At that time it is showing the 3.5. Next, repeat the same experiment with the 3 meter length of the wire. At that time we are observing 3 milliampere current will be flowing. So first 1 meter length of the wire we are placed between the P and the Q and observing how much current is flowing through the circuit and noted in this one. Repeat the same experiment by, okay, using the 2 meter and the 3 meter one upon the other, means one after the other one, and noted the corresponding ammeter readings. So, but we know that according to the Ohm's law, V is equals to IR, then R is equals to V by I. What is the relation between R and I is there? If flow of current is more, resistance is less. If I is less, R is more. Here in this one we are observing that, so the I value is gradually decreases, means I is decrease means R is increases. At the same way here, what is increasing? Length is, means when the length is increases, flow of current is decreased. So that's why we can say that, Okay, so if the length of the conductor is increases, okay, flow of current is decrease, means nothing but resistance is increase. That is the relation between R and L. So from this experiment, what you are understand or conclude means, okay, the resistance is directly proportional to the length of the conductor. That is one is there. Next one, okay, prove the Snell's law. What is the Snell's law? We know that the ratio of, okay, sine of angle of incident to the sine of angle of refraction for a given pair of media is always constant. That is what means sine I by sine R is equals to constant. That is the Snell's law is there. So now how to prove the Snell's law means with help of semicircular glass law. First of all, we can take a drawing sheet. It is fixed on the drawing board. Now we can take a protractor. The protractor, okay, sorry. Now we can take a, okay, pencil, draw a line at the middle of the paper. Now we place a protractor below this line, okay, like this more, and draw the markings of angle. After that one, now we can take a semicircular glass slab. Already on its surface, they are already marking in angles is there. Now the semicircular glass slab is placed above this line is there. So like this mode is there. Now we can take one laser light. The laser light will be focused at any one, okay, selected incident ray. Listen, take one drawing sheet fixed on the drawing board. Now we draw a horizontal line at the middle of the drawing sheet. Now we can take a protractor, place the protractor below the horizontal line and, okay, draw the angles. Now after that, now we can take a semicircular glass slab. Already on its surface they graduated the readings or marking in readings is there. That is placed like this one is there. This is the, okay. Now we are observing that. Now we can take one laser light and one incident ray will be selected in our mind, like for example 20 degrees is there. So I is equals to 20 degrees. Is there. Now the laser light is focused on the 20 degrees. So the light will be, okay, passing through this, okay, line and fall on the, okay, semicircular glass slab. Here listen, okay. So this part we can as the radar medium because of here there is no any, okay, object is there, only air is present. But above this one we place which one? A semicircular glass slab. So glass is the denser one because of, okay, it is when compared to the air it is denser. This one we can see as the refracting surface. So the incident light passing through the 20 and fall onto this point. Here the light ray behaves as to traveling from radar medium to denser medium. We know that when the light ray travel from radar medium to denser medium, it will be deviate from this path and move towards the, bend towards the normal and passing through one line. Now the refracted ray come outside through this glass slab. At what angle? That is gives the refracted angle. That is we are noted to here. That is anyway. Now repeat the same experiment. Okay. So by considering different angle of incident like 25, 30, 35, 40, 45, 50 like this one. So and noted corresponding angle of refraction values with help of this one is there. So that one. Next sine 20. This value is coming is there. So for example here, okay, 18 is there. So sine 8 like this. Just finally sine I by sine R values you can find out that in every case that value will become is 1.5, 1.5, 1.5. So finally we can prove that sine I by sine R for a given pair of media. Here which is the pair of media? Air and glass. For this pair of media, what is the refractive index? Means 1.5. So that is the way of that. And the last one, okay, there are the different types of lenses and write their names. We know that very easy, this one is there. So how many types of lenses are there? Two. Convex lens and concave lens is there. So in the convex lenses, how many types are there? Okay, three. First one is okay. Biconvex. Second one. Okay. Equiconvex. Third one. Plano-convex. Convexo, concave. Next here. So like this. Convex and concave are totally four types are there, each one. Convex, biconvex, equiconvex. What is the difference? This one means equiconvex means okay. So this is the R1, R2 means R1 is equals to R2. That type of convex lens we call as okay equiconvex lens. R1, this is the R2. R1 is not equal to R2. So that is we call as biconvex. Here two radius of curvature, here two radius of curvature are there of concave shape. But in this one, R1 not equal to R2, that is the biconvex. R1 is equals to R2, that is called as equiconvex. Next, this is the plano-convex. Plano means it is the plane, it is the convex. That's why plano-convex. In this one, convex shape, concave shape. That's why convex of concave. Next, in concave lens, biconcave means R1 not equals to R2, same like this. Equiconcave, R1 is equals to R2. Next, plano-concave, plane concave, plano-concave. Next, concave, convex. That's why concave, convex. These are the types of lenses and their names.